All right, today we're going to be talking about Chapter 5, Lesson 8. It's called Factor Linear Expressions. So when we start talking about factoring linear expressions, what we like to do is factoring monomials. And what we do is we find the greatest common factor. We're going to practice doing that first, and then we're going to practice using this method to actually factor the expressions that we have. So monomials are single-term expressions. Mono means one. If something has more than one term, remember terms are separated by an addition or subtraction sign. So this one has two terms, two terms, two terms. This is not a monomial. This one is not, and this one is not, because there are two terms where monomials have only one term. So when we practice finding the greatest common factor of monomials, we use prime factorization to help us. So first thing we're going to talk about is finding the greatest common factor of 48x and 28x. So let's focus on 48x first. What we like to do is we look to simply do the 48. Because x, we can simply write down as one of its factors. The reason why is because x can't be factored. We don't know what x is, so x is all by itself here. Next thing we do is look at 48. What we like to do when it comes down to prime factorization is try to get down to factors that are prime. Remember, prime numbers are numbers that are only divisible by 1 and itself. So let's try to start off with 2, because 2 is prime. And I can get to 48 by doing 2 times 24. So this is one of our prime factors. So I'm going to put that next to the x. Continuing on my tree, I want to do a 2 again. Now 2 times what is 24? Well, that would be 12. Here's another 2. I'm going to put that here again. As I continue, I can change 12 into 2 times 6. Here's another prime number. That's 2 again. So I'm going to put that again along my prime factorization for 48x. Last one here, 6 is 2 times 3, and both of those numbers are prime. Now, one way to check to make sure that I did this right is to multiply the numbers together. If I can get to 48, I know I did this correctly. So 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 3 is 48. 48 times x would be 48x. So this is the prime factorization for 48x. We're going to do the same thing for 28x. I'm going to remove the x and look just simply at 28. So 28 is 2 times 14. There's a prime number. We're going to put it right here. 14, we can split into 2 times 7, and both of those are prime. So 2 and 7. And if I do this again, 2 times 2 is 4, times 7 is 28, and 28 times x is 28x. Now, to find the greatest common factor between them, what we do is we look for pairs. Both of them have an x. Both of them have a 2, both of them have a second 2, and that's it. There isn't a 7 up here, there aren't any more 2s, or there isn't a 3 down here. So to find our prime factorization now, we multiply the numbers that are in here. So we split this in half, and we multiply one of the set of numbers. So x times 2 times 2. So the greatest common factor is 2 times 2 is 4 times x is 4x. Example 2, finding the greatest common factor of 14ab and 28ab. So I'm going to write down 14ab, 28ab. Now I keep the variables over here, so a and b, a and b, and I look at just $14. So 2 times 7. Those are both prime numbers, so I leave it as 2 times 7. Over here at 28, I have 2 times 14. 2 is prime. And then 14 would be 2 times 7. And both of those are prime. Again, I'm going to look for pairs. Both of them have an A, both of them have a B, both of them have a 2, both of them have a 7. So I'm going to split this in half and multiply one number from each pair. So I have 7 and 2 and A and B. 7 times 2 is 14, times A is 14A, and times B is 14AB. So the greatest common factor is 14AB, which happens to be one of the two terms we were looking for the greatest common factor of. Which makes sense because this to this is a times 2. All right, let's practice factoring expressions then. So what we're going to do is we're going to utilize the greatest common factor to help us factor linear expressions. So first thing we're going to do is we're going to factor 12x and 48 because those are separate terms. I'm going to leave x all by itself here and look at 12. That's 2 times 6. And 6 is 2 times 3. So my prime factorization is at the end of each one of these branches. So 2 times 2 times 3. 48 doesn't have a variable attached to it, so we're going to do 2 times 24. Continue the process. 24 would be 2 times 12. 12, we know, is 2 times 2 times 3. So at the end of each one of these branches is a prime number. There are 1, 2, 3, 4 2's and 1 3. So 2 times 2 times 2 times 2 times 3. What we're going to look for now is pairs. So here's a pair, here's a pair, here's a pair. So the greatest common factor would be 3 times 2 times 2, which happens to be 12. Now, this number here goes outside the parentheses. What's left, then, is what goes inside the parentheses. Now, if for some reason we would have gotten that there wouldn't have been anything left outside of pairs, you would have had to put a times 1. But in this case, we're okay. We have an x left here, so we're going to put an x. 2 times 2 is 4, so I'm going to put that there. And the original problem called for addition, so I'm going to add them. So the factored form of 12x plus 48 is 12 times x plus 4. Last question, factor 3x plus 11. Again, there's an x here, so I'm going to leave x out. I'm going to factor 3 and 11. Now, 3 is already prime, and so is 11. Which means that if there isn't a pair, because there isn't an x or a 3 down in this 11, and there isn't an 11 up in 3x. So if there isn't a pair, the greatest common factor is 1. And if you get a greatest common factor of 1, or there are no pairs that happen between these two terms, we say that this cannot be factored. All right, that is the end of lesson 8. If you have any questions, please let me know.